So on page 157, we're discussing solving problems with data represented in bar graphs, dot plots, and circle graphs. Those are the three kind of graphs that we're going to be looking at. We're going to solve problems that involve the proportional relationships found in graph data, including part-to-part and part-to-whole relationships. And we're also going to figure out how to make a circle graph using percentages, since we talked about that last unit, and the number of degrees in a circle. Now, the number of degrees in a circle isn't really something that you're going to be tested on when you take the unit test or when you take the STAR, but it's something good that you need to know for 8th grade and high school. Let's skip this part and get right into it. Thank you. So, with the people sitting around you, we're going to look at the graphs that are shown. This is going to be an open discussion, provided that you wait your turn to speak, and I'm going to jot things down that you suggest. So, in a minute, or after a minute, my timer will go off. I want you to tell me what you see in these graphs. What's similar and what's different, because we're going to have to write that down. You got a minute, go. Just put it down. What do we see that's alike? Yes, ma'am. Yes, ma'am. They have the same information. What else is alike? Yes. Huh? Okay, it's useful info. Anything else? Yes. Do they both use percents? So then that's a difference. This one uses percents and this one uses what? Whole numbers. We call that quantities. How many shoes were sold? Oh, they gave off little generic names. E-Rock, like Reebok, Nike, like Nike, and Adi, like short for Adidas. That's funny. Of course not. So one uses percents and the other uses quantity. And then what's the obvious difference between the two? Yes. One is a circle and one is a, what kind of graph is this? Bar graph. There are two kinds of graphs, or two different kinds of graphs. Bar and circle. Two kinds of graphs. Well, yes, usually there's going to be numbers involved in a graph here, but not always, but usually. All right. Will the number sold and the percent sold always be the same? For example, if 3 additional pairs of basics are sold, will the percentage change to 103%? I need to know why or why not. Thank you. I heard somebody say no. Can you tell me why? Well, let's see what we have. How many shoes were sold here that were this brand? How many were sold here that were this brand? Nope, it's not touching 35. Let's say 32 and we'll give or take unless we need to. I need y'all to pay attention. Are you catching up with what you missed? Okay. Right here, what's this? What's this? No, look at this. This is on the line. This is on. I'm looking at other. Hold on. Yes. Other's 15. Now what's this one? Let's say about 18. Okay. Now let's add them up. 25 plus 10 plus 15. 25 plus 15 is 40, plus another 10 is 50, and 32 plus 18. What's my total? 100. Okay? So then if I add 3 more basics, I'm going to have how many shoes then? 103, but what would the total percent be? I sold 100 pair of shoes. What percent is that?
100.
Then I sold 103 pair of shoes. What total percent is that? Still 100. So is it going to stay the same? Is this going to stay the same? Is this going to become the same number? Are these always the same number? What if I sold 110 pair of shoes? What percent is that? Let's say this is my monthly sales. So for March, April, and May, what's the percent of shoes that I sold in May if I sold 110? It's all of the shoes that I sold. What is changing? The quantity. So why will the numbers always be 100% as the total and not always 100 over here? Because my total is changing. My total number of the things, that's the quantity, changes. The percent is always going to be a whole 100. So will the number sold and the percent sold always be the same? No. The quantity changes, but the total percent is still what?
100.
Good. Okay, we've got another times observation to make. Study the graphs until I call time. You'll get a minute. Then discuss your observations with your partner or somebody next to you or near you. What do you observe about the sum of the percents? Sum means I need to do what? Okay, what do we observe? They all equal 100%, which is the whole. So each sum should be 100. Now moving along, what do we know about a full circle? No, because this is 180. Say what? 360. 180 plus 120 plus 60 is 360. All of these should add up to 360. This is going full circle. All right, stay focused. Is it possible for the data from a bar graph to be transferred to a circle graph? Explain. Well, where did we see that transformation happen already? At the top, they gave us the same data. One was in bar form, the other was in circle form. All they did was convert. Yes, the numbers or quantities need to be converted to what? Good. Starting tomorrow, y'all are going to have to turn your phones in a bucket so that I can determine whose phone keeps going off in my class, and then you'll have to pay $15 to get it back since you're failing to remember to turn it off. And this is third period. Maybe that little fee will remind you not to have your phone on. I don't care if you use it in somebody else's class. The sound should not be on. Furthermore, it's a distraction, because what did all y'all do? Look around. Whose phone was that? Instead of staying focused on what's going on in front of you. I don't think you have any passes left. Not right now. Bar graph. Natasha, you should have handled that before class, honey. What does a bar graph show? Okay, but is this what all bar graphs show? Because didn't we just look at shoes? So what do they do? How do they display data?
They show the number. They show the quantity of it.
The quantity in a what? Starts with the G. No. Each one is a what? A group. Grouped data by category. I like that definition better than the one that I use. So hard to go. Circle graph. What does it show us? Percents. Parts of a. Good. And a dot plot shows the word that I have not yet mentioned, but I think one or two of y'all in the room are smart enough to figure out what I am trying to get you to say. A dot plot shows how often something is repeated. If something is repeated a lot, we call that what? Besides repetition. It's a synonym of repetition. It starts with an F. No. Fiction.
What's the next letter?
No, I'm not going to give you the next letter. It's doing something a lot. Your parents might say this.
Biting.
Biting? No. Doing something a lot. It's repetitive. What?
Frequently.
Yes. Aw, shoot. Frequency. Thank you, sweetheart. Dot plots show frequency. How often something is repeated. Okay? So, how many times did people choose A when y'all did your survey last week or 2 weeks ago? How many times did people choose B? Okay, that's frequently. So, in this graph down here, it's how frequent is the number of matches 50 in a box. Okay? Percent. Part out of what? Of the whole is what though? This is specific. Part of 100. Proportion. When she gets back. No. 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 You have these notes. You've been given these words before, except for radius. That means flip back in your notebook and figure out what they are, because Miss Starling's not doing the thinking for you. It has to do with the circle. It's half of the diameter.
Oh no.
Real quick, a radius is a ray with endpoints on the circle and the center. Here's the center, and then here's the other endpoint. This is a radius. Here's the center. Here's another endpoint. Here's another radius. There are 1, 2, 3, 4, 5 radii. Still want to know what a proportion is?